So today we are going to focus on one concept of section 7.1, which is the nucleosome. So I like to make these video lessons using BioNinja, which is a really good site that you can use for higher level topics. As you can see here, you can go to any of the higher level topics and then you can look at any of the core contents. So if you need this supplemental video, if you weren't in class, if you were absent, or just as a review, we will be using these video lessons. So let's start with the nucleosome. So the first thing we want to understand is what is a nucleosome and what is the purpose of a nucleosome. So notice here, the basic understanding is that nucleosomes help to supercoil the DNA. And we find this in eukaryotic organisms. So DNA has to be packaged in some way. So if we look down here in this picture, we see that DNA in the molecular form is just naked, right? So here we see the double helix form. It is just a naked form of DNA. And then what happens as the DNA kind of starts to coil itself up? So I kind of think of like a rubber band that's starting to coil itself up. Well, that DNA has to wrap around something. And what it wraps around is these histone proteins. So this structure right here is what we call the nucleosome. So before we actually look at the structure of the nucleosome, let's look at the overall organization of the eukaryotic DNA. So like we said before, we start out with our naked DNA, and this is just the double helix. And then we move on to a more organized form and a more compact form, which is the nucleosome. And this is what we're going to focus on in our lesson. What does this structure look like? Then we see that these nucleosomes can keep winding themselves into what we called a chromatosome, which is the next level of eukaryotic structure. Now, something to think about here is that both in the nucleosome and the chromatosome level, we find active genes. Then within the solenoid level and the 30 nanometer fiber level, we find less active genes. Okay? So we see here that these chromatosomes keep winding themselves up. So again, think of that rubber band just like winding and winding and winding itself up into a string. So this solenoid structure then condenses itself even further into a 30 nanometer fiber structure. And then these fibers form these loops, which are then compressed and folded even further, and they form chromatin. And you've probably heard of chromatin before, which is what we consider our loose DNA. It's still active DNA, but it's loose DNA. It's very tightly wound DNA, as you can see here. And we can find chromatin during interphase in the cell cycle. And then if we keep wrapping that DNA, then we will have our most condensed form, which of course are our chromosomes. Now, we only see these chromosomes during the metaphase stage of cell division. That's when they are visible if you stain them under a microscope. Okay, so this is how DNA in a eukaryotic organism can organize itself. Okay. All right, so now let's move down a little bit further and let's look at a diagram of the nucleosome. Now, within your understandings here in IB Bio, they want you to be able to recognize the nucleosome using this molecular visualization software. So this is what it would look like under a visualization software. Okay, so you should be able to recognize this as a nucleosome. Now, a diagram of the nucleosome, kind of like a side view, this is what it would look like. So what is the composition of this nucleosome. So you see that it consists of a molecule of DNA. So here's your DNA in red. Okay, so it's a molecule of DNA that gets wrapped around a core of 8 histone proteins. So we call this an octamer because you see 1, 2, 3, 4, 5, 6, 7, 8 histone proteins. Okay, now there's different types of histone proteins that make up this octamer. You don't need to worry about that. In your visualization software, you'll get to see the names of these histone proteins like H2A, H2B, H3, or H4. But just know that it's an octamer, and when you build this in your activity, you'll be able to see it even further. Okay. So you have about 146 base pairs of this DNA that wraps around this octamer here. And then you have an additional histone protein, and we call this the H1 histone protein. And notice that this is like your linker protein. This is what's going to allow the DNA to link up initially, right? And then it wraps around the octamer. So this H1 histone protein kind of just further facilitates the packing of this DNA, okay? So let's see, what else is there to know? If you were to click on this top view, and I think we can do that right now. Oh no, we can click it here. It takes you to a JMOL software program where you can actually play around and look at the nucleosome. So here you see the DNA, and in this particular case, let's see. In this particular case, the histone proteins would be in blue, and the DNA would be wrapped around in red. And then you would see here the little tail, and that little tail would be part of that H1 histone protein. Okay? So that's what your nucleosome looks like. And that's our first video.